One thing I would like to mention last class, that is last Tuesday, while I was recording. So when I left, actually, maybe there is some reason the network was slow or busy, something like that. Because of that, the video was not recorded properly. It just, I mean, the screen that I have shared, it was not visible in the video, just my voice was there. So I thought it don't have any meaning just posting the audio clip. So that is why I just mentioned that there is some error. So please go through the slides. If you have not attended the class session, then please go through the slides and let me know if you have any questions in the hierarchical clustering. So hopefully I won't have that type of issue today while recording. So let's just start. So starting with DBScan. DBScan full form is actually density based spatial clustering of applications with noise. So the name looks big. So it is actually a well known data clustering algorithm that is commonly used in data mining and machine learning. Okay, so whenever we want to cluster or group certain points, the most famous or most chosen approach is your DBScan. K-means is also helpful, but most of the time the DBScan is more effective in terms of determining the outliers or forming the cluster. So what does it mean by that? Those outliers and everything, we will look into them later. So based on a set of points, as I told you, DBScan groups together the points that are close to each other based on a distance measurement. And as you know, most of the time for distance measurement, we consider the Euclidean distance. And here, in along with the distance measurement approach, we do also consider some sort of minimum number of points. So what is that minimum number of points? We will look into that in this DBScan approach. So this also marks the outliers as the points that are in low density region. So what does it mean? So based on the highly dense points or the regions in a location where there are set of points which are more close to each other. So we call them as highly dense region. So that highly dense region is considered as a DBScan cluster. So let's say there are certain points in the data set which are not um, actually which don't actually belong to the highly dense region. So what to do in that case? Those points are considered as your outliers. So let me annotate it so that you will be able to understand it properly. So what I'm saying, suppose like this, this is a cluster and okay. So this is a cluster, this is a cluster, and here you have another cluster. So if you see which areas, so based on this arrangement of data set, how can we group the points? So we can take this one as one cluster, this one as one cluster, this one as one cluster, and this is the only point left in another cluster. So it's based on how dense the area is actually, how closer the points are to each other. It's based on that we form the clustering. Okay, so if we are considering this cluster with respect to this point, so what do we say? That this point is not belonging to the highly dense region. That is why it is called as an outlier, which doesn't belong to this cluster. So these outliers are really necessary while forming the clusters in your DBScan. So let's look into more details of it. So what is this? If you see in this picture, B, C, D, E are some points, and there are certain round or circles around them. So actually, these are nothing but the region covered by these points. So the point A's region is this whole big circle. Accordingly, B, C, D, E has their own region. So how These regions are actually formed. These regions are actually formed by two different um, major aspects. So what are those? Major aspects or parameters, you can say. So DBScan algorithm mostly requires two parameters. One is epsilon. Here you see epsilon, the sign, okay, and okay, sorry, and then the mean points. Okay, there are two different parameters. So what is epsilon actually? Epsilon specifies how close the points should be to each other to be considered as a part of a cluster. So that means if the distance between 2 points is lower than or equal to the value of the epsilon specified, this value, then those points are considered as neighbor. So see this A point and its region. So there is a certain epsilon actually assumed. Okay, and for the D point there is certain epsilon assumed. So based on that epsilon, the region is formed around the point, and any points which fall inside that region, they become a cluster. Hope you understood that. And what is mean points? Another parameter. The minimum points or the mean points, um, they are actually used to form a dense region. Okay, so if, for example, let's say if we set the mean points parameter as 5, then we need at least 5 points to form a dense region. If you see, if you look into this picture, this is a cluster. A is a cluster. So what is happening here? Why A is placed so far from these points? Because if we are considering, just ignore for the epsilon for certain point of time, just consider the mean sample. Let's say we consider the mean sample as 4. Okay, so what happens here? Let's say make it 3, because we have only 4 points. So with respect to D, we assume that if the minimum points are to be considered as 3, so within the epsilon region, we define minimum numbers that are the 3 points are needed to form a cluster together. So A, it is with not within the region, and also it is not falling inside the mean points range. That is, it is not inside the 3 mean points. So that is why we consider the A as an outlier. So that is how the epsilon and the mean points are considered, and they play a major role while forming a cluster in the DBScan. Let's see more detail. Um, so three different points are again here: core points, border points, noise points. So based on the two parameters that I just explained, epsilon and mean points, the data points are classified as core, border, and noise points or outlier. So what is a core point? So a core point is something if there are at least mean points, number of points, including the point itself, okay, in its surrounding area with the radius as the epsilon value, core points. So here we can say that with respect to D, the C can be a core point because it is falling inside the epsilon parameter value and also satisfying the mean points, total minimum points. The border points, that means a point is a border point if it is reachable from the core point and there are less than mean point number of points with its surrounding area. So here we can say, uh, let's say consider this region around the D. So there may be certain core points, but as they are touching the border region of the cluster, so here C, E are considered as the border points. So if we consider this whole cluster as a whole with respect to D, so here we can say B can become a bordered point because it is close to the border of the whole region. We will look into more clear picture of understanding these points. Um, then the noise points. So noise points are also called as outlier. So if there is a point which is not a core point and not reachable from any of the core point, in this case we can consider A is a outlier or a noise point. Okay. So how the DBScan works, let's just understand that. So first, for each point or each instance, the DBScan algorithm will actually count how many points are located within the assumed epsilon value, that is the radius. Okay, that is one parameter. So after you get that, so if an instance or a data point has at least minimum samples, let's say you specify the minimum points or samples as 5. So in order it to the point to be considered as a core point, you need to satisfy that that point has that many or 5 number of minimum samples surrounding itself or including itself. That is how the DBScan works. So in other words, if you can say, core points are those which are located in the dense region, which are close to each other mostly. Okay, just one moment. I'm looking for a picture. I'm not added this here. Hold on a second. Okay, let me annotate it then. It will be easier that way. So let's say we have a point here, 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 here. Okay, and these are the connections. We just, if we want to connect, then there are other 2 points as well. So every points are connected to each other in some way. Okay, so these are the points, just to just for the sake of understanding. Then here we have 1 point, here we have 1 point, and there is a connection from this point to this point. And then we consider another point, blue point. Okay, fine. So here what I can say, so see, there are the regions are to be created in this way for each of the point, based on their epsilon values, their region. So this whole thing we can consider as a one cluster. So C is also within attached to this region, and yeah, the yellow point, this has this region and blue has its own region. Okay, so here what happens, if in this case we consider the mean points to be assumed as 4. So here what happens, we are considering the minimum points as 4. So the red points are actually considered as core points because there are at least 4 points within their surrounding areas with the epsilon value or the radius value. Okay, and the area is shown with the circles as I just formed surrounding them. The yellow points are considered as the border point because they are reachable from all the red core point, but have less than 4 points within their own neighborhood. They are placed far from the main core points, the red core points. So here reachability means being surrounding in the area of a core point. The point here yellow, 2 yellow points, these points including themselves also. So within their neighborhood, that is surrounding the area with the radius of the epsilon defined. Okay, uh, so in that way, we just consider them as the border point. Finally, we have another point, blue point here that you see on the top, that is considered as a noise or an outlier because it is neither a core point nor it can be reachable from any of the core points. Hope you understood what is the meaning of core point, border point, and outlier. And they are most important to understand the DBScan algorithm.
So could you go back to that diagram that you drew?
Oh, sorry. Actually, I was just annotating.
Oh,
So
I think I can ask the question without it. So
yeah.
the blue dot that you had drawn and said that that's an outlier. So the
Mhm.
distance from the blue dot to the red dots was larger than the epsilon value, and that's why it's considered its own cluster.
Yes, it depends on the epsilon as well as the mean samples also. Okay, so let's say the blue point, okay, in that in its closer region, as we define the minimum points to be as 4 points. Let's just keep the epsilon aside. As the minimum points is considered as 4, so closer to the blue dot we didn't had any of the points, any that is minimum satisfaction, that is 4 points, it was not there surrounding the closer to the blue point. It is far from other points. Okay, far from the core points as well as the border points. That is why it is considered as the outlier, and most of the time they are considered as the noise, and which are not useful for analysis in the data set. If we look into the in more detail here, these are the steps actually for the algorithm. So arbitrarily select any point in the cluster, that is in the data set. Then first find out or retrieve all the points in the epsilon neighborhood. So it depends on, here you need to consider both the parameters, the epsilon as well as the mean points, and this is something you need to assume it initially for your analysis. So now you need to decide if P is considered as a core point, then a cluster can be formed. Okay, but if P is a border point, so no points are in the epsilon neighborhood or in that epsilon distance from the point B, and DBScan will visit the next point in the data set, whole data set. So you keep on doing the same thing until all the points, let's say you have 10 points, until you cover all the points one by one in the data set. This thing is to be frequently repeated. And after doing all the steps again and again, when you are completed covering all the points, let's say there are certain points still who are not able to be assigned to the clusters, those are nothing but your outliers or the noise points. Again, to define that, what are the core, border, noise point, I added some more information. So DBScan mostly locates the regions of high density that are separated from one another by regions of low density. So there is a center-based approach. What it does actually, the density is to be estimated for a particular point in dataset by how? By counting the number of points within a specified epsilon, that is within a specified radius, a number that you assume for that point. So you already seen what is a core, border point, noise point. Okay. Next, let's see here what it says. Here we are considering A as a core point, B as a border point, and C as a noise point. How? So there is a defined region or parameter value for epsilon radius. Okay, so here are the epsilon or the radius value for forming a region or a cluster region around it. If we define the mean points as 7, so considering A, you need to find out, are there 7 points within closer to its own region. So A has certain points closer to it. So for this region of epsilon, we can consider A as a core point. But see, so B actually is what is happening. B is considered as a border point, so it is in the neighborhood of the core point, but it is not a core point actually. So why do we have that? Because so B is considered as a border point because it is not a core point, and mm, which contains at least one core point but in its own region. So B region is this which does not contain the minimum point, 7 number of points within its own region. So that is why it becomes the border point. Now the noise point C. So what is why do we consider the C as a noise point? Oh, one moment. Okay. So C is considered as a noise point because here it is neither a core point nor a border point. So core point, why it is not a core point? Because it doesn't has the specified number of mean points within its own region. Okay, and here also it is not considered as a core point. Yeah, core point, I just defined that. And it is not considered as a border point because it is not in the neighborhood of the main core point. So if we consider A as a core point, B as a border point, then with respect to this whole region, C becomes the noise point or the outlier. So we always have to see what is the epsilon. The define based on the epsilon, we define the circle or the region around the data point. Then you have to define or determine which is the core point based on the mean points. So looking into that, you need to decide which are the border points and which are the the outlier points or the noise points. If we do DBScan, as the two parameters are most important, epsilon and mean samples. Okay, so considering or assuming the epsilon may affect your results very drastically. So how? See here the difference. Here we are considering epsilon at 0.05 and here we are considering the epsilon at 0.20. So see how the clustering is visible to you. So here you see here one set of data points that are they're in the same region kind of, but they are not so much differentiated from each other. But if we increase the epsilon value, the clustering will be done in this way. So based on different types of problem domain and data set, it may affect your results or analysis. So in this case, we need to carefully look into choosing the parameters, mostly the epsilon value. Next, here see, suppose we are considering epsilon value as 10 and mean point as 4. You see the two pictures here, these are the original points, and depending upon the color values, we are differentiating them into core, border and noise points. So epsilon 10 means what? It specifies that the point should be close to each other with a distance of 10 to be a part of cluster. That is the epsilon. It means that if a distance between 2 points is lower than to this value of 10, then these points are considered as neighbors. Okay, and mean points 4, that means minimum number points 4 is needed to form a dense region. So for example, if we set the mean points parameter as 4, then we need at least 4 points to form a dense region. But if you are considering the point with respect to a given point, then you need to consider actually 5 points in the dense region, 4 plus 1. So this is how there are different types of clustering formation. So sometimes DBScan is efficient in terms of handling the noise points because K means algorithm, if you remember, it doesn't have that much ability to differentiate the outliers effectively, but if DBScan does have that, so it is resistant to noise. and it can also handle clusters of different shapes and sizes. If you see, this is a varying set of data sets. So sometimes, sometimes also it can handle shapes, but sometimes it may not work well with varying density. Okay, so let's say you have different clusters with different set of densities. If you see this region here, then you need to be careful for selection of the parameters of epsilon and the mean points. Same data set with the epsilon value 9.97 and mean points 4 is differentiating the cluster in this way into three different sets, whereas here based on the 9.92 it is differentiating the cluster into only this into a different format. So this type of result will it may bias your determination or assumption capability. So that is why epsilon and mean points are needed to be chosen carefully. Here, see this picture here that it shows. Okay, so in picture A, the epsilon is chosen as 0.5. Okay, same data set, and here the B, actually the epsilon is 0.4. So just see how the clustering is being visible in a different way, just with a difference of 0.1 of the epsilon value. Again, same data set, if we see for mean points 4 and epsilon 0.5, this one only one cluster, then for 3.5, this is the how the clustering is formed, and for epsilon 3 it is giving you a different set of illustration here. So your epsilon and mean points are very needed to be chosen carefully. So the thing is that if you have a data set and while choosing the epsilon and mean points, needed to be chosen carefully. So what is the effective way or the easy way to find that? So there has been some sort of research been going on, and one one approach is there where I'm going to show you in the next slide. So one approach is there. So using that, to some extent, you may be able to be successful to choose your epsilon and the mean points effectively. Okay. Here, let's see that slide. So here for choosing the epsilon and mean points. So the main idea is for points. Let's say you have set of points, multiple set of points in the cluster. So there you need to define the k nearest neighbor. How many nearest neighbors are there roughly at the same distance? So there is actually a algorithm. So using Python, if you write a code, there is a simple format of that. I'm planning to show you that how to actually implement this in the code using if you are familiar to Python. I'm planning to do that, show you in the next couple of classes. So for defining the epsilon and mean points, you need to choose this nearest neighbor format, one approach. So we need to define that the noise points have the k nearest neighbor, okay, at the uh, farther distance. So there is a plot like this. Here this plot actually sorts the distance or arranges the distance of every point to the k nearest neighbor. And here k can correspond to also the mean points. So actually what does it mean? You are basically sorting the points according to the nearest neighbor, and here the nearest neighbor you need to determine what nearest neighbor you need to choose. Here this picture has considered fourth nearest neighbor. So what it shows actually, this picture considers a sample data set. So the value of epsilon is determined in this way. Actually depends on the k value. The way I was showing you kth nearest neighbor. So here you need to assume a k value. So, but the k value doesn't change dramatically as the k value changes. Here actually k value is changing like this, 0, 5, 10, 15 like this. So here at certain point, the curve actually, I mean, it was going like this at a certain point in this, it starting to be constant. So there are different ranges. So if most of the time while you take your data set and you apply this k nearest neighbor format assuming a k value, then there you need to see where the maximum curvature is here. So based on that you need to determine what should be your epsilon and what should be your mean sample. Okay, so if there are also different disadvantages. If you choose the value of k, that is the k nearest neighbor, if you choose it too small, then even a small number of closely placed points that are noise or outliers, they will be incorrectly labeled as clusters. So if you choose this k value as shown in this plot here, if the k value is too small, then s- if some of the points are very close to each other, in that case also they will become as your outliers. So suppose say if you choose your k value uh, as very small, the minimum number of points as very small, so let's say you are considering it k value as 2. Okay, then what happens, still these 2 points are very close to each other, because but as you are assuming this very small, so these 2 points are becoming outliers or noise, which is not good for our analysis. Okay, so and then if the k value is too large, then small clusters which of a size less than the k value, they are likely to be labeled as noise. If there is a point here, if you consider the k value too large, let's make it 20 or 30, then the whole thing will become a cluster. Again, this is also not something that we want. So what we can do for this given plot that you see here, so for this plot the given chosen value of k will appear to be a reasonable value for most of the two-dimensional data sets. So this is not again easy to understand. Once you implement it, then it will be easy to understand. So we don't know what is the epsilon minimum sample. We need to go through this plot and there we see where is the maximum curvature. So based on that we determine the epsilon and the mean samples value. So here the searching of the epsilon value is done by calculating the slope of the line here where the maximum curvature is from any point, and it is sought after pair of points that have greatest slope to locate the point, and the slope of a line is located at point of 10 here. Okay, and a point which is the optimal value of the epsilon. Okay, and there also again determining this becomes your epsilon, but again you need to think about your minimum points as well. So how to find that, it will be helpful if you will go through the code to look at it, how do we define the or determine the epsilon and the mean points. So this is the whole description about your DBScan. So just go through the chapter, the book, okay, and see how the DBScan works, and see if some of the examples are there. Now I would like to just mention to you that um, the chapter 1 is due soon. Okay, sorry, the assignment one, I'll be giving you another one assignment based on mostly this clustering, this clustering chapter. So please go through the chapter content and similar type of assignment will be provided to you. So